What's up, guys? Welcome back to Peaceful Coding, and today we're going to look at how to make Pong as a web application with zero dependencies. So let's just go ahead and jump right into it. I've got my command line open to my home directory, and so let's go ahead and enter my workspace folder, and we'll make a new folder for this project. We'll call it Pong. Cool, so we'll go in there, and let's open up this folder in VS Code. All right, fantastic. So I'll make the interface a bit bigger here. And let's start off with this web application by making a few files. We'll make an HTML file. And inside our HTML file, we're going to put just kind of our starter HTML. You can do this in VS Code by pressing exclamation mark and pressing enter on that first thing. And let's also go ahead and add some JavaScript here. And we possibly might need some CSS as well later, but let's start without it. And if we need it, we can add it. Okay, so from here, let's go ahead and update our HTML file to have a reference to our JavaScript file that we just made. And so to do this, we're going to make a script tag at the bottom of our HTML file here. And let's use the autocompletion to add that main.js. Fantastic. Let's actually test that this thing is working now. And to do that, we'll just put some kind of simple statement in our JavaScript. For now, let's just log out hello world. Great. Okay, so now let's open up our HTML file with the browser. And so to do that, we can just reveal this in the Finder and double click this HTML file. Okay, nothing looks to be here, but if we inspect, and I'll go ahead and make this all bigger. Let me put this on the right side and do some major zooming in here. There we go. We can see we've got our hello world statement that's coming from our console log statement over in our JavaScript. All right, so fantastic. So let's go ahead and start adding the things that we need for a Pong game. And the first thing that we're going to want to add is the Pong ball. So let's just go ahead and make this an element on the screen. Well, we've actually got a couple options here. We could either add the ball in the HTML and control it from the JavaScript, or we could add it in the JavaScript and also control it in the JavaScript. Let's go ahead and just add it in our HTML here. And so we can just make a div for this thing and give it ID ball. And then we'll go ahead and we'll grab this inside of our JavaScript. The other thing is I think it is actually a good idea for us to have a CSS file here. So let's go ahead and do that. And we'll make a file called style.css. And let's reference that in our HTML. So we can do link and then link CSS. And that'll autocomplete to the CSS syntax. This actually looks good already. Style.css matches up with our file name here. Okay, great. So the way that we're going to do this is let's position our ball absolutely in our document here. And so to do that, we can use some CSS rules to essentially say we're going to control the position of the ball via its coordinates pretty much, instead of the typical CSS/HTML way of laying things out where, content is kind of laid out in rows, top to bottom. So to do that, let's first actually make a container in which this ball will go. And this container will just represent pretty much the whole screen's content. So we can call this container or something like that. And you can note that it is actually possible to use classes instead of IDs to reference our elements. It doesn't really matter which we use here. Typically, classes are used to style elements, whereas IDs are typically used to grab elements and control them in JavaScript, but technically we can use either one to do either purpose. So let's just use IDs for our example. Okay, so for container, let's go ahead and add some style rules. And to do this, we're going to go ahead and reference the selector of this element in CSS, which for an ID is going to start with this pound sign. And then let's go ahead and give it some properties. And so we're going to say that this is an element that's going to take up the entire width and height of the screen. So we can say the width is going to be 100% of the viewport width, and the height is going to be 100% of the viewport's height. So VW and VH for viewport width and viewport height. Okay, and then additionally, we want the children of this element to be positioned absolutely. And so we need to give this thing a position relative. And that is just kind of how it works if you want its children to be able to be positioned absolutely. Okay, so now for the ball, let's go ahead and say that this thing has like a width and height of, I don't know, 50 pixels maybe. And let's go ahead and also give this a background color. So we can say that this is, let's just make it blue, and actually let's make it black. And then let's also go ahead and give this a border radius to curve the edges. And so we'll say that the border radius is going to be half of the width, so 25 pixels. Okay, great. The other thing we need to do is we need to say, let's position this thing absolutely, and let's give it some kind of initial coordinates. And we're actually going to end up changing these coordinates in the JavaScript, so it doesn't really matter if we put these in here or not, but let's just do it for example's sake. So we'll say top, that's going to be the top edge of the ball, and left is going to be the left edge of the ball. We'll be 20 pixels away from the top of the parent container and 20 pixels from the left of the parent container. Okay, so if we refresh this, there's our ball, and our container is invisible, but it is taking up the entire width of the screen. It actually looks like we've got a little bit of extra scroll state here, which is pretty weird. One way that actually may be because of the built-in margin that exists on the body element, and so you can see that the container, there's a little bit of white space that's hard to see in between the actual body, kind of body tag of this document. So let's go ahead and delete this margin on the body. And so to do that, we'll come up here and we'll reference this thing by its tag name, body, and say that this thing's gonna have 0 margin. All right, there we go. We got rid of our scroll bars. Okay, so from here, let's actually make this ball bounce around with JavaScript. And to do that, we'll go ahead and first reference, we'll kind of grab the ball with JavaScript. And so we'll say that our ball element is going to be, and then we'll go ahead and use query selector to grab this thing, and we'll grab it by its ID ball using that same selector that we saw in our CSS. Okay, so from here, what we're going to want to do is we're going to want to code in some kind of position and speed of our ball. And so the speed or velocity is going to determine kind of what direction our ball goes in, and the position will determine the position of the ball. And so this thing is going to have an X position and a Y position. And so let's go ahead and make this variable ball position. We'll make this thing an object in which we'll store 2 values, which will hold the X position and the Y position of the ball. And so let's just say that this thing starts out at 0, 0. And additionally, let's go ahead and define the velocity of the ball. And we can say that it'll also have an X velocity and a Y velocity. And let's just say that these are both 1 and 1. Okay, great. So from here, what we're going to want to do is we're going to set up kind of an infinite loop that'll just keep running over and over again. And every time the loop runs, we're going to update the state of our ball, and we're also going to draw it in a new location. And so let's go ahead and set up that loop. So we can just call this game loop or something like that. We'll make this thing a function, and then let's go ahead and set this thing up to be called over and over and over again. And we could just maybe make a while loop and run this thing infinitely, but turns out the browser is actually not going to be able to handle that many calls to drawing the ball, and so it's a bit better to use this function called a request animation frame. And what this does is it's a built-in function that exists in the browser, and it will call the given function as soon as it's able to draw or render content again in the browser. So if we said, go ahead and as soon as kind of an animation frame is available, call the game loop function, it'll do that. And then in order to make this thing loop, we're going to need to also call this from within our game loop, so that we call this function, we do a bunch of stuff, and then once all that stuff is done, we go ahead and loop and call it again. So there we go. The other thing is, technically, we could simplify this a little bit by removing this one, and this will just essentially say, hey, when this code is read, call the game loop, and from there, that'll kind of initialize the process of once the game loop finishes, call itself again as soon as an animation frame is available. Okay, awesome. Okay, so from here, let's go ahead and continue our example, and what we'll do is we'll add some code which will update the ball's position based on its velocity, and then we'll also have some code draw the ball at its current position, because although we've defined the position here, there's nothing that actually tells our HTML element ball to be drawn at that position. So let's make two to-do statements. The first one is going to be update the state of the game. And then the second one is going to be render the ball at its position coordinates. Okay, awesome. So let's start here. And what we'll need to say is every time the loop runs, let's go ahead and adjust the ball's position to be incremented by its current velocity. So we'll do that for both the X component and the Y component of the ball's position. And we can just say ball position dot X is going to have the velocity added to it. So we can either say is equal to ball position dot X plus ball velocity dot X, or we can just say plus equals ball velocity dot X. And then let's go ahead and do the same thing with the Y. Okay, awesome. So we took care of that to-do comment. We could honestly leave a comment here that says, let's not even bother. Okay, and then from here, let's go ahead and render the ball at its position coordinates. And so we'll say that, let's just say well, we have a choice here. We could either say that let's put the top left of the ball at its X and Y coordinate, or we could put the center of the ball at its X and Y coordinate. I kind of think that I could go either way on this one. Let's just start simple and we'll just draw the top left of the ball at its XY coordinate. And so we'll say, okay, let's grab this HTML element and let's set its style.top property equal to ball position.x. And then, actually top has got to be Y. Let's do XY in that order. And then we'll say that left is equal to X. Cool. Okay, so we took care of that to do as well. Oh, and somehow I lost my brackets. Let's put those back in. Okay, perfect. So this looks pretty good. Let's go ahead and try it out. So we'll refresh. Uh-oh, nothing's happening. So let's do some debugging here. And what we'll do is, let's see if this loop is being run over and over again. So we can say, let's add some kind of console.log statement in here to see if anything's actually happening. And it is happening. So from there, let's go ahead and see. It's possible that we botched this syntax here on setting the left and top property of the ball. And it's also possible that something else is going wrong entirely. So let's look at what the ball's position is. And we'll delete this old log to simplify things as much as possible. And if we refresh, okay, we can see that the position is updating, but the ball is not. So maybe the problem lies in how we're styling this thing. And so let's just actually Google it. So set style property on HTML element with JS. Yeah, it looks like that syntax is correct. You know, the one thing we may be missing is we may need to add units to this. So right now we're just setting this to a number, but let's actually go ahead and try to add, make this a string where instead of this being 10, for example, we'll make it 10 pixels. And so let's use a template string to do this. This is a string that you can essentially insert variables into. And so this is a string that has kind of the number followed by pixels. And let's see if that works. Oh, yep, it did. So let's go ahead and apply it to the other position value as well. And there we go. We can see that as our position is incrementing, our ball is moving down right, and it moved way off the screen. And it's actually adding a scroll state here now, which is kind of weird. So one thing we may want to do is let's actually make it so that we cannot kind of like overflow out and start scrolling. We'll do that in our CSS by adding a property to our container that says overflow hidden. And we can test this now. Yeah, overall this does look good. I guess one thing to note is as its X and Y position increase, it's moving down and right. So down being a positive Y value is kind of weird, but it is what it is. We could adjust that, but let's not even bother. Okay, so we got rid of the scroll bars. That looks good. Let's make it so this ball actually bounces around the screen. And so we can do that by looking at the borders of the screen. So we can get the pixel values of the bottom of the screen, the right side of the screen, and we know that the top left is 0, 0 right now. And we can add some conditional statements in here that says, if the ball hits the side of the screen, go ahead and bounce. So the first thing we'll need to do is we need to figure out how big is the screen actually. And I believe that's window dot inner height and inner width. And so let's actually try that out. So these are just built into the browser as well. So I believe it's inner height and inner width. And let's actually log these in the same thing like this. All right, so let's check that out. We'll refresh. Okay, cool. And it looks like that is correct. If we resize the screen, we can see that that Y value changes as well. Okay, cool. So that's great. So let's go ahead and say if the ball hits the bottom of the screen, so if the position of the ball position, let's actually keep our kind of world updating code and our rendering code separate. And so I'll put the rendering code down here. It doesn't really matter. It's just kind of a minor nice thing. Okay, so we'll say if ball position dot y becomes greater than the height of the window, window dot inner height, go ahead and make the ball position dot y negative. We could just say let's multiply by -1. We might possibly get in a weird situation where if the ball ever gets super off the screen due to some edge case, it'll just start rotating back and forth as it multiplies its y velocity by -1. So let's actually make sure we explicitly say the y velocity of the ball needs to be negative if it goes beyond the height of the screen. And so to do that, we can go ahead and say, okay, ball velocity dot y is going to be set equal to the negative version of the absolute value of ball velocity dot y. And then we can do a similar thing for bouncing off the right side of the screen. And to do that, or maybe we should take care of bouncing off the top side of the screen first while we're working with y. So this is the bottom of the screen. Let's do the top of the screen here. We'll say if the ball position.y is less than 0, make this thing positive. We don't need, we don't need to put that plus sign in, so we'll just leave it as the absolute value. And then let's add similar statements to handle bouncing off the left and right sides of the screen. And for that, we'll look at the sort of x component of the ball. And I'll just grab all these things, substitute them with .x, and then let's grab the inner height thing here and switch that to inner width. Okay, I'll get rid of this console log, get rid of some of these other lines, and let's check it out. Let's also make this faster. So we'll make the velocity like that. Okay, cool. So one weird thing, okay, we've got an issue. So I kind of botched the code a little bit here. So we've got ball velocity, ball position. That makes no sense. So we wanted these to just be ball velocity. Okay, and let's try that again. So what I was gonna say is one weird thing here is that the ball kind of goes all the way until its left side hits the side of the screen. For the bottom and the right, you can see that that actually did not happen with the top side. So let's go ahead and update those conditional statements to take into account the width and height of the ball. And so we'll say if it's gonna go beyond the height of the screen minus its the ball's height itself, and that is stored in our CSS as 50 pixels. So we could let's just add a variable here that's ball size to avoid having magic numbers, as we call them, which are pretty much numbers that don't have any label and can get kind of confusing how we got to them. Okay, so we'll subtract the ball size from the width of the screen, and we'll also subtract the ball size from the height of the screen here, and we should see that that thing should actually bounce. All right, awesome. So it's looking good. Let's just add some paddles now, and let's do one computer paddle and one human paddle. And so let's start with a computer paddle on the right side of the screen. And to do that, we're actually gonna need to code in like a little bit of an AI, but that's totally fine. The other thing is we have all this ball related code. Let's actually abstract this to another function to stay organized. And so we'll call this update ball. And we'll put all our ball updating code related in there. All our ball related updating code in there, rather. And then we'll call that function from our game loop. The other thing is maybe it makes more sense to call this update world or update game or something like that, just to match our terminology here. Okay, so from here, let's go ahead and set up one of the paddles. I said we're gonna do the computer paddle first. I think it actually might be more complicated, so let's start with the human paddle, and we'll put that on the left side of the screen. So first off, let's make a element in our HTML. Call this human paddle. And there we go. Let's also add some styles for this thing in our CSS. So we'll reference it by its ID again. And let's say height 100 pixels, actually probably 200 pixels with 25 pixels. And then we'll go, yeah, background black, position absolute, left will be 0. And when you're using the 0, you never have to use units in CSS, kind of convenient. And then let's say that the top is just 0 to start out. Okay, and there we go. We've got our paddle here. Now we just need to do a couple things. One, we need to make it so that the player can control it. And then the second thing is we need to make it so that the ball actually bounces off the paddle. So let's go ahead and start with the controlling bit. And to do that, we can create an event listener on our document, which is really just the browser, that says when the arrow keys are pressed, go ahead and do something. And so we can say that add event listener. And I think we're going to want to do key down. And then we'll put an event handler function in here. And so this says when a key down event happens, call this function, and also the function is going to have access to this key down event. And so first off, let's just see if this is working by doing a console login here in which we'll look at that event. And I'll come back to the browser, refresh, and when I press stuff, we can see that, certain stuff is firing. The other thing is we probably want it to be, well, this is fine. Let's just do it this way. So let's look inside this keyboard event. It is a big object with a whole bunch of properties, and part of those properties is it tells us what key we just pressed. So you can figure out which key has which code by pressing various keys and looking at the code over in the console here. Okay, so let's actually get rid of that console log now that we've seen what we need to see, and we'll say, okay, if they pressed, what was that? So if event.code is equal to arrow up, we will move the paddle up. And wait a sec, we don't have any variables or anything that define the paddle information, and so let's go ahead and do that. And so we'll say, I think I made this 200 pixels high. Oops, this is gonna be human paddle height. Let's just, we'll call it human paddle. Okay, so we also want human paddle width. We're gonna want that later. 25, and then human paddle position. We can really only move the paddle up and down, so let's not bother making it an object. Let's just make it a simple number. We can call this position Y. And you could also argue that we should just do it like this and be kind of consistent with our syntax from before. And let's actually go ahead and do that. I do like consistency. Okay, and we'll also go ahead and do a velocity. And even though, yeah, this will just have kind of one single property, no need for an X, since the X will never change. Okay, great. Actually, we might not need a velocity because we can just say that when they press the up arrow key, just change the position a bit. And we'll want to change it by some increment. We can call that speed or something like that. And let's say that the human changes by 10 units every time they press the up arrow key. So we'll say if they press up, go ahead and subtract their position. So human paddle position dot y, and then we'll say subtract from that value the human paddle speed. Awesome. Let's also go ahead and handle the up arrow case. We'll say, okay, otherwise, if they pressed arrow down rather, let's go ahead and add that paddle speed to their Y position. Okay, so nothing's happening. I gotta refresh, but nothing's still happening. And so what we forgot to do here is we forgot to say, hey, in our update world game loop, let's actually go ahead and draw the paddle at the position that we've defined here. Because once again, there's nothing that connects this notion of position to our actual HTML element for the human paddle. And so we'll say human paddle element is equal to document.querySelector human paddle. Awesome. Okay, perfect. And so from here, let's go ahead and write some code that'll actually draw the human paddle at that position. And we can abstract that into its own function. just to keep everything nice and organized. And in here, we're essentially going to do something very similar to this. However, we're only dealing with the y of the paddle. And so let's say, okay, the top of the human paddle element is equal to human paddle position dot y. All right, and look at that. We are moving around, so we now are controlling this thing. The thing we need to do now is we need to say, hey, actually make it bounce the ball off of the paddle when they collide. So to do that, we'll want to add some code to our update ball. So this is like bounce ball off screen screen sides or window sides, whatever we want to call it. And then let's also go ahead and first check to bounce the ball off of human paddle. Okay, so to do that, we're gonna say the ball needs to be, well, let's make this ball square to make the collisions a little bit easier, actually. Yeah, that is probably the move, because doing an accurate circle collision might be kind of difficult when it comes to detecting an intersection between the ball and the corner of the paddle. So this is going to be nice and easy. It's just a visual change. We'll just remove this border radius property. Refresh. Okay, there we go. That's going to make collisions a little bit easier. Because now we can just say if the top of the ball is greater than the top position of the ball is greater than the bottom position of the paddle, and it is lefter, more to the left than the right side of the paddle, we have a collision, and then we'll have to do a similar check for the top of it. But we have kind of a sort of few if statements we can do to detect that collision. So we'll say, okay, first off, the ball is going to need to be to the left side of the right side of the paddle. So let's write an if statement for that. So if the ball position dot x is less than the width of the paddle, human paddle width, and it is, and the ball position dot y, the y position of the ball is less than the top, and we need to think real hard for a second about the thickness of the ball and how that's going to affect it. So we'll have to say if the ball position dot y is less than the ball position dot y plus, so we're looking at the top of the ball because that's how we define everything, plus the size of the ball is less than the top of the paddle position, and and we're not below the paddle, so we need to add one more of these that says we're not below the paddle, ball position dot y, and we're looking at the top of the ball. If that is, and it's, oh, hold on, this actually should be greater than, I think, greater than, then this should be less than. So, and the y position of the ball is less than the bottom of the paddle, which is defined by human paddle position dot y plus the height of the paddle. Then we want to bounce. So we should say move the ball towards the right, set its x velocity to the absolute value of itself. Okay, perfect. Let's see if that actually works. So we just need to, we need to refresh. And then let's make this thing a little faster too. It's still pretty slow. Okay. Boink, 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 and nice. Okay, it worked. And let's make sure that if it's not hitting the ball, cool. I also realized we let the paddle move right off the screen, but whatever. We don't need to spend time coding that in. Okay, so that's great. The other thing we need to do now is we need to make the computer paddle. So let's do that. So we'll go ahead and let's just copy paste this, call that computer paddle. We could call it AI paddle, whatever. And let's go ahead and add some style rules for this. It's going to be very similar to the human paddle. We're just going to want to say that the right side of the paddle is going to equal 0 instead of the left side. Other than that, this should be able to stay the same. And let's see if that worked. Oh, no, we're not seeing anything. So let's go back and this all, oh no, that should say computer paddle. There we go. Okay, there it is. So perfect. So what we want to do is we want to code in an AI here. Probably the easiest way to do this would be just to make it perfect and say just always set the paddle to be in front of the ball no matter what. That would probably be the easiest way, but it wouldn't be very fair. And so probably a more fair way would be to say, look at whether the ball is above or below the computer paddle and then move it towards it by some increment. And that can be the speed of the computer paddle, which we can then make slower if we want to make the game easier because the computer paddle may not be able to reach the ball in time, and we can make it faster to make the game harder and potentially impossible if it can just always, get the ball. Okay, so let's go ahead and code this thing up. We'll just go ahead and copy some of these variables for the human paddle, and let's change this to computer paddle. The thing is maybe we'll put this with the human paddle code just to kind of keep our stuff together. So ball, human paddle, computer paddle. Okay, so we don't need to add an event listener to say listen for the user pressing arrow keys. What we will need to say is move the computer paddle in the direction of the ball. And so let's go ahead and create an update computer paddle function here. And there really was not much in our update human paddle thing in the end, but still doesn't hurt to keep things nice and organized. I'm messing this up. Const. Okay, there we go. Okay, so in here, let's go ahead and say detect whether the ball is above or below the paddle. And so we'll say, let's make a Boolean that says, is ball below computer paddle? And to know this, we're going to look at the center of the ball. So maybe we should put that in a variable. Ball position center y is going to be ball position dot y plus half of its size. So ball size over 2. And then let's also get the computer paddle center position. Computer paddle center. Computer paddle position center y is going to equal computer paddle position dot y, and that's also going to be plus half the height of it. So computer paddle height over 2. Okay, awesome. So now we can just say if we know that the ball is below the computer paddle if the center of the ball is greater than the center of the computer paddle. Computer paddle position center y. Okay, cool. Okay, so finally we can say if the ball is below the computer paddle, go ahead and move the paddle down by its speed. So let's make the computer paddle kind of slow. So I'll say that it just has 1 speed. And to do this, we'll go ahead and update the computer paddle position dot y. And to make it go down, we need to add something to its y. So we'll add computer paddle speed. And then otherwise, we'll say go ahead and subtract computer paddle speed. Okay, perfect. The last thing we need to do is we do need to render the HTML element at the variables we have for the computer paddle position, and that'll look very similar to how we're doing the human paddle. Oops. Whoa, where am I? Okay, so we can just switch human to computer here, and the rest should be good. Okay, great. Let's see if this actually worked. Oh, the other thing we're going to need to take care of is, okay, that didn't work, first of all. But the other thing we're going to need to take care of is bouncing the ball off of the computer paddle. But let's fix this issue first. So doesn't really look like anything is happening. Oh, maybe it's because, yeah, there we go. So we had our query selector incorrect here, and we were selecting the human paddle, which actually you could see that the human paddle was moving like the computer paddle should have. Okay, so if we refresh, looks good, and it's pretty slow. Maybe we speed it up a little bit. We'll double it. Seems good enough. And let's go ahead and make the ball actually bounce off of it. And so that's also going to look very similar to our bouncing off the human paddle code. And so inside of our same update ball function, we'll have one more set of if statements to bounce the ball off the computer paddle. And I think this is more or less just going to look exactly like the other one with human substituted for computer. The only thing we need to look out for is the X position, because instead of saying look for when the ball is on the left side of the screen, we're going to say look for when the ball is on the right side. So when the ball position X is greater than the screen width minus, so window.inner width minus the width of the paddle, computer paddle width, computer paddle width, there it is. Okay, let's see if this actually works. Ah, I missed, we gotta wait again. Come on, computer paddle. No, okay, let's make it faster. So, we'll just do that. Actually, it kind of looked like it did not work. Let's review what we've got going on here. Oh, you know what? So to do the right side of the ball, we need to, so this is the left side of the ball. So the right side of the ball is going to be this plus ball size. Okay, let's try that. Nope, that definitely didn't work. Oh, here's the other thing. We said make the ball go to the right if it does it. So you can see that it's pretty much glued to it now. So let's actually go ahead and say make the ball go to the left if it collides with the computer paddle. Nice. Okay, that definitely worked. Awesome. Okay, cool. So the last thing we might want to do for our game is add some scoring. And we could add a couple scores up in here. And so let's go ahead and do that. So we'll make a couple more elements. So human score and computer, or yeah, human score, computer score. And we'll go ahead and style these things. This is also, now we'll just be repetitive. I was thinking, hey, maybe we'll go ahead and kind of reuse some of the CSS we're going to write for each of these scores, but no need, honestly. So we'll say font family mono, give it that good retro look. Let's make this font size like 24 pixels, top, 20 pixels, and then left, I don't know, something like that. And then computer score, we'll do the same, but we'll make it on the right side. Okay, and then there's nothing in these elements right now, so they're not going to immediately show up. Let's go ahead and update our JavaScript to contain the scores. And so we'll want to first query select those score elements, and we'll also want some variables in which to put the scores. So we could say scores is an object with human and computer, or we could just say, let's make two variables, human score and computer score. The other thing is, because these are primitive variables, they're not objects, we're going to need to make these variable declarations as lets, and this will allow us to reassign these values later on. We didn't have to do that in the case of using these objects because we were just reassigning the values inside, not the actual object itself. Okay, so let's call this human score element, and we'll query select it based off the human score, and we'll do a really similar thing for the computer score here. Okay, awesome. So the last thing to do is we need to say, let's render these scores. So let's actually put this value inside of our score element. And so we can do something like this, update scores. And we'll just say, go ahead and set the inner text of these elements, human score element dot inner text. You could also use inner HTML here, shouldn't really matter, is equal to the human score. There we go. And let's do the same thing with the computer score. That looks good. What is this about? Oh, it doesn't like that that's a number. So let's make it a string. So we could actually just call it the toString at the end of this thing. Is that the issue? What's going on here? Something else is wrong. Oh, these brackets are square brackets instead of curly braces. So let's make these curly braces. Okay, there we go. That was weird. So it's fine that these are numbers. No need to stringify them. Okay, the other thing we want to do is we want to say, so let's actually look at this. Oh, nothing's showing up, so let's fix that. Human score, computer score, that looks good. There are those elements. Maybe we're styling them. Oh, you know what? We're going to need position absolute to use this top right absolute position styling syntax. And there we go. Okay, they're kind of small. Let's make them a little bit bigger. Sweet, there we go. And let's make them like a little bit like transparent as well. So we'll set them to 0.5 opacity. All right, awesome. So from here, let's say that if the ball hits the left side of the screen, then we'll go ahead and increment the appropriate person's score. So let's go back into where the ball bounces off the window sides, and we'll say that if we're bouncing off the left side, in addition to ricocheting, we will also go ahead and add one to the computer score. So computer score plus plus. That's one way of saying plus equals 1. You could also just do, doesn't matter. Okay, so let's also do the same thing for the human score when it hits the right side of the wall. So human score plus plus. And let's test this. The computer is probably too good to test it, but we can, oh god, okay. Yes, that worked correctly. Okay, so far so good. And there's our game. The last thing we could do is we could say, hey, let's make the speed increase every time it hits a wall. And so we can say start the ball's velocity at 1, and every time, and let's make the computer paddle a little faster too to make this game like a little more manageable. Yeah, there we go. That's kind of better. Okay, that is way too slow to start with. Let's start at 2.5. Okay, and we'll say every time it bounces, speed the ball up by a little bit. And I'm kind of looking at all these instances in which we have different bounce code, and I'm thinking, is there any way we can not repeat ourselves here? And probably, but let's just go ahead. We'll just say that when it hits a paddle, speed up by 1. So if you bounce off the human paddle, ball velocity dot x plus equals, we'll just add a little bit to the x and y velocity of the ball. And let's also do the same thing in the case where it hits the computer paddle. And actually that's like not very much. Let's make this a little more interesting and do 0.5. Holy. Why is it so fast? It seems like it started off incredibly fast. Maybe that's because it started ricocheting with the paddle. Maybe we need our starting position of the ball to be more like 100, 100 to prevent that kind of initial collision. Because I think it started inside the paddle. Oh, it just slowed down? Huh? Okay, why did it slow down? Oh, because you know what? If the ball has a negative velocity, then it should, the x should... Okay, so I realize that we have a little bit of a quirk here in that we're dealing with positive and negative velocities, and so we can't just always add to it because it might slow it down if the velocity was negative, as in it was going left or it was going up. So the easy way to deal with this is we say, hey, we're just not going to mess with the y velocity and add to the x velocity if it bounces off the computer paddle, and alternatively subtract from the x velocity if it bounces off the... I messed up which paddle is which, but I think you get the point. If it bounces off the computer paddle, make it go left faster, and if it bounces off the human paddle, make it go right faster. Yeah, and that's pretty good. That should make this game interesting, and we'll see. Can we beat this computer? We might need that y velocity to bump up, because otherwise it's not any more difficult for the computer to hit it, because it's just, oh crap. Okay, computer's racking up points on me. Okay, let's... that was actually pretty fun, but let's try to make it so that the the velocity increases. And so to do this, we're going to abstract this all to a new function because I realize it's going to be too much code to just encapsulate, like to kind of repeat here. And so we'll just say that increase ball speed is going to be its own function, and say to do, and then anywhere that we want to increase the ball speed, we can just call this function. And how this is going to work, so let's actually, now that we have this sweet function, let's also just go ahead and say anytime the ball bounces anywhere, go ahead and increase the ball speed. And in here we'll say that, okay, oops, if the ball velocity dot x is positive, then go ahead and add to the ball velocity. And maybe we should define something ball acceleration for this value. Let's do that. It'll be just nice if we want to tweak stuff later. Okay, let's go back down to where we were. And whoa, no, we wanted to say this. Okay, so if the ball was going to the right, go ahead and increase its velocity by the acceleration. And if it was not, if it was going left, then go ahead and subtract it. And then additionally, we'll do the same thing for the y velocity of the ball. So we'll say if it's y velocity, oh, and we need to add dot x here and dot y here. Cool. So handle making it go faster, whether that's subtracting or adding, and do the same thing for the y velocity. Holy, okay, so let's see how this works now. Okay, so it's getting faster already. Okay, it's already speeding up. This is a proper challenge. All right, we're winning. Holy, okay, it's getting a bit too fast, but that's cool. I think we accomplished what we wanted. So anyways, that's it for today. That is how you make Pong. Hope you enjoyed the video. And if you have any other kind of like simple arcade games that you want to see made in the future, go ahead and leave a comment. And yeah, we can get into that. So thanks for watching and see you later.